Okay, today's class we will discuss the problems on even and odd functions of the signal. In the previous class, we gone through how to solve a problem when it is given in the signal in a continuous form. Here, we are going to solve a problem based on the discrete time signal. Here, a problem it is given. Determine and sketch the even and odd component of the discrete time signal, that is x of n, shown in figure. Okay, a signal is given where it is varying 0 to 5 with the amplitude as 1, and from -1 to -5 as the amplitude of -1. This is what the given signal. Next, the solution. What we already know, what is the even part of the signal, that is xe of n is equals to 1 by 2 x of n plus x of minus n, and x, this is odd xo of n is equals to 1 by 2 x of n plus 1 by 2 x of minus n. These two are the equations we already come across this. Next, what we have to do, already x of n signal is given for us. What is the equation is going here? This equation I can write as 1 by 2 x of n plus 1 by 2 x of minus n. Yes, we can write the equation as like this. Here, first I done, that is 1 by 2 x of n, means the amplitude is going to be scaled by 1 by 2, means multiplying with the amplitude 1 with the 1 by 2. So if I multiply each amplitude of the signal from 0 to 5, the 1 is there. If I multiply with 1 into 1 by 2, means I will be getting as 1 by 2. The signal is going to be reduced by half position. Okay, that is what, from 0 to 5 it will be going for with the amplitude as 1 by 2. In the same way we can do for the discrete values from -1 to -5. If I multiply -1 with the 1 by 2, I will be getting as -1 by 2 from -1 to -5. Then same thing I can do for the second term, that is half x of minus n. When I'm doing this, what is x of minus n? It is a reflection of the signal, right? Already 1 by 2 x of n is done. The same thing, the reflection operation, right? The positive values are going to be taken in a negative way, and negative values are going to be taken in a positive way. This is what the reflection. Already we gone through with the theory part. Okay, the same thing, just I reflected the samples here. What is going to change? Zeroth value will be remain same as from instead from 1 to 5 it will be taken the positive values of the amplitude in the negative side, and negative amplitudes in the negative, it's going to change towards the positive time with the amplitude as negative, that is 1 by -1 by 2. This is the reflection of the given signal. Then what we have to do, we have to add both the signal. When I do adding of both the signal, here from -5 to -1, here it is negative values minus -1 by 2, and here from -1 to -5, here it is of a positive values, and here it is of a negative value. Here -1 by 2, here +1 by 2. If I add both the signal, what I will be getting? I will be getting as a 0 only. For that reason, from -5 to -1, it will be 0 only. Means you will not get any samples. Then at 0, what we have? At 0, we will erase this. At 0, what we have? Here it will be half, and here it is Also, the amplitude is 1 by 2 only. 1 by 2 plus 1 by 2 you'll be getting as 1. At 0, you'll be getting the amplitude as 1. The sample amplitude as 1. Then at from 1 to 5, here is the positive 1 by 2 amplitude. Here is the negative 1 by 2. 1 by 2 minus of 1 by 2, it will be going to be 0. For that reason, here you don't get any samples, it will be 0 only. So when you add both the signal, you'll be getting the value as at 0 only, you'll be getting the amplitude 1. That is the even part of the signal. Then when you want for the odd part, what you have to do for the odd part? What is the equation? 1 by 2 x of n minus 1 by 2 x of minus n. We already done 1 by 2 1 by minus 1 by 2 x of minus n we done. What we have to do? Here it is a negative value, right? Just multiply the whole signal by negative. Multiplying with the negative. What I will be getting? The positive values are going to be changing to the negative. Here, observe here. The positive 1 by 2 from minus 5 to 0, it is going to change to negative values of minus 1 by 2 with the amplitude, and the negative values of the amplitude from 1 to 5, it is going to change when I multiply with minus, it's going to change to the positive values of the signal, that is from 1 to 5. This is what minus 1 by 2 x of n signal. We got this, and we already having what is our 1 by 2 x of n signal, right? So now what we have to do? Now we have to add 1 by 2 x of n with the minus 1 by 2 x of n, because already I wrote what is our minus 1 by 2 x of n. Okay, what we have to do? We have to add these two signal, this one and also of these two signals. Now if I add 1 by 2 x of n, what is going to be here? Minus 5 to minus 1, minus 5 to minus 1, the amplitude is of minus 1 by 2. Here minus 5 to minus 1, the amplitude is of minus 1 by 2. So minus 1 by 2 plus minus 1 by 2, what I will be getting here? You will be getting as 1 only. Understanding? Okay. Here it is of a minus 1 by 2. I told we have to add, because already we added done minus 1 by 2 x of n, for that reason. Minus 1 by 2 will be getting as 1 only. So the amplitude is going to change to 1 here, from minus 5 to minus 1. And at 0, at 0th position, here it will be 1 by 2. And at 0, here it is the minus 1 by 2. Plus 1 by 2, minus 1 by 2, it will be 0. For that reason, you will not get any sample here. It will be 0 only. At 1, from 1 to 5, here 1 to 5, amplitude is of 1 by 2. Here at 1 to 5, the amplitude is taken as 1 by 2. 1 by 2 plus 1 by 2 will be getting as 1 only. Here I wrote. This is the amplitude of 1, and it will be continuing the signal. Okay, this is how we have to solve for the discrete time signal. Next, here the next problem, a figure it is given. For us, we have to find even part and also of the odd part. Here, what we already know, what is our the equation for even part and also for the odd part. Just what we want, we have to go for 1 by 2 x of t. If I do 1 by 2, my scaling with 1 by 2 means it's going to decreased by, amplitude is decreased by half position. For that reason, from minus 1 to 1 half, again from 1 to 2, it will be minus 1 by 2 signal. Here minus 1 is there. If I multiply 1 by 2 means minus 1 by 2, you will be getting. Then we have to go with the 1 by 2 x of minus t, reflection of the signal. X of 1 by 2 x of t If you reflect that, you'll be getting your 1 by 2 x of minus t. Just to reflect this operation, positive values are going to be negative and negative is going to be positive. So you'll be getting like this signal. This is your 1 by 2 x of minus t. Then what you have to do? We have to add these two signals. So I'll be getting as my even part. From minus 2 to minus 1, it will be minus 1 by 2. For that reason, minus 1 by 2. From minus 1 to 1, minus 1 to 1 here, half. And again minus 1 to 1, again here, half. 1 by 2 plus 1 by 2, you'll be getting as 1 only. Then from 1 to 2, here you don't have any signal. Here 1 to 2, you have a signal that is with the amplitude of minus 1 by 2. For that reason, 1 to 2, you'll be getting as only minus 1 by 2 signal. Okay, this is your even part. In the same way, if we do for the odd part, what you have to do? You have to subtract these two signal. We have to subtract these two signal. This is 1 by 2 x of t minus of 1 by 2 x of minus t. Here, what we will be getting? Here we don't have any signal. Okay, it will be 0 minus of minus 1 by 2, right? From minus 2 to minus 1. From minus 2 to minus 1. Here is the negative value. Minus 1 by 2 amplitude is there. Here is 0 is there. 0 minus of minus 1 by 2. What will be getting? Plus 1 by 2. Mention here 1 by plus 1 by 2. Then across from minus 1 to 0, here is 1 by 2 minus 1 by 2. What will be getting? 1 by 2 minus 1 by 2 means it will be getting as 0. For that reason, minus 1 to 1, it will be 0. Again from here, 1 by 1 to 2, here is of a minus 1 by 2. This is the amplitude. Then if I 1 by 2 minus, here we don't have any signal, it will be 0. So what will be getting? This signal remains as it is. That is 1 to 2. Amplitude is going to remain as 1 minus 1 by 2 only. Okay. This is how we have to solve the for the given signal to find the even and odd part. And the next problem, here somewhat in different way it's given. What it is given? First we read of that. Figure shows part of the signal x of t and its even part x e of t. X of t is given and x e of t it's given for us. Respectively, for t greater than or equals to 0 means t value, time period value, it is varying from 0 to positive values, right? T is greater than or equal to 0 only. X of t and even part xe of t for t less than 0 is not shown. Less than 0, here is a 0. Less than 0, it is not shown for us, right? Yes. Complete the parts of x of t. We have to complete the what is the structure of our x of t and xe of t. Xe of t also we have to find the complete structure and also draw the odd part of x of t. That is x odd of t. Here x of t signal is given and also xe of t signal is given. They are telling that it's not a complete signal. These two are not a complete signal. Okay. Then we have to complete both the signal, that is xe of t and also of x of t, and then we have to find what is odd part of the signal. Okay. Next, how to find this? First, we will go through the characteristic of a even signal. What is a characteristic? We told while going for the theory part, even part of the signal is symmetric about the x-axis, right? Based on that condition, I can complete my even part of the signal. Here it is wrote, the even part of any signal is symmetric about t is equals to 0. Symmetric about y-axis. That's what. Thus, the complete even part XE of t is shown in figure. That is XE of t is nothing but that is XE of t. Here 0 to 2, a triangle shaped signal is already there. The symmetric of this means the same is going to be reflecting here. That's what here it is drawn. From 0 to 2, it is having a triangle signal. Then the reflection of this symmetric means the same thing at the other side also. Symmetric about the y-axis at 0. That is means y-axis. So the same triangle you have to draw here from 0 to minus 2. This is what the whole XE of t. We got our XE of t, what is asked for us. Next, we go for the next part, that is we can find of x of t and also of the odd part. Okay, before that we know that the equation x of t is going to be equals to even part of the signal plus odd part of the signal. Means a signal is consisting of both even part and also of the odd part. What we have to calculate? We have to calculate for the x odd of t. For that reason, we will write x odd of t this side, and x odd of t is going to be taken as x of t minus x e of t. Okay. Then consider t is greater than or equal to 0. Here it's given for us only at the t value where it is greater than 0 only. Okay, for that reason x of t is given 0 to 1. The same signal here it is drawn with the amplitude as 2. Then x e of t. X e of t, here what I did, I am considering of this signal here taken. Here I am taking and multiplying for the negative value. Means if I multiply the whole signal by minus means the amplitude is going to be multiplied with the negative value, so it will be reflecting down. So that's what here I drawn. Instead of positive value, if I multiply with the negative, it will be changing to the negative values from minus 1, minus 2, 1, 0 to 2. This is your x e of t. That is x of t we got, and also minus of x e of t we got. Next, I can find out, just we have to add these two signal. When I add these two signal, first you observe here from 0 to 1. From 0 to 1, here the amplitude is 2, and here if I just draw a dotted lines, okay, this is how the structure is going for minus 1 to minus 1. Here the amplitude is changing from minus 2 to minus 1. Observe here at 1 the amplitude is changing from minus 1 to minus 1. It is rising and it's going to reach at minus 1. For that reason, here it is a positive value 2 and here is the negative value. When I just observe here, what I can do, we are going to add these two signal at 0. At 0, here is of 2, here is of minus 2. 2 minus 2, it will be 0 only. Yes, it will be 0. Next, if I take at values of 1 by 2, right? At 1 by 2, what is the value I will get at 1 by 2? In between value I am checking here. Okay, here it is of what? 2, right? And here 1 by 2 if I take, here if I take 1 by 2, what is the value? It may be in between 1 and minus 1 and minus 2, correct? 2 minus of in between value. What is, it is less than minus 2 only, maybe of 1.5. Yes, 2 1.5, 2 minus 1.5, what will you be getting? 0.5, right? 0.5 means positive 0.5. For that reason, it is going for the positive way, increasing in the positive way. Then if I check at 1, what is the value here? It will be minus 1. At 1, here it is the 2. 2 minus 1 will be getting as 1 only. Correct? Understand here? I took 1 by 2 in between value. At 1 by 2, here it is 2. At 1 by 2 in the signal, it will be 1.5. 2 minus 1.5 will be getting as 0.5. For that reason, at 2, it is giving the positive values. For that reason, it will be rising edge. Rising. Okay? Rising edge. Then at 1, what is the signal? Here it is 2. At 1, here it is minus 1. Understand here? At minus 1. 2 minus 1 will be getting as 1 only. For that reason, it is rising till 1. Then here we don't have any signal. What we left with the signal? This only triangle, right? The same thing. Here it is drawn. It is just taken this triangle and it is replaced here. Just this is what how you will be getting your odd part of the signal. Okay, it's a simple, just go down and it's going to be drawn. That's it. The same, this triangle is reflected here because here we don't have any signal. For that reason, this is your odd part of the signal. Then from this we can complete, this is the half part, that is when t is greater than equals to 0. When I go for the odd part, the odd part of any real signal is anti-symmetric about the t is equals to 0. Even part is symmetric, odd part is asymmetric. For that reason, this anti-symmetric we can draw like this. Observe here, we already got off from t to t greater than 0 values. Just anti-symmetric signal you have to draw this. Just make with the anti-symmetric signal. So you'll be getting your x odd of t. Just how it is the same, you will take in the other side. This is how you have to draw for the anti-symmetric signal. Okay, it's not a mirror image. Okay, this is not in a mirror image, it's a reflection of that, reflecting. Okay, this is how x odd of t you will be getting. Then what you have to do, we have to find what is our x of t. It is of only in the positive values. What about the negative? We have to go further. For that reason, we already got our x odd of t and also x even of t. We have to add these two signals. So you will be getting your x of t signal. That's what here wrote. X of t is equals to x e of t plus x odd of t. Then observe here. We have to add these two signals. I will take a darkening one. We have to add these two signals. From minus 2 to minus 1, a small triangle with the amplitude as 1. And here, minus 1 to minus 1. Just observe here. If I check with the, what is the amplitude is going for at 1, minus 1, it is going to be taking the amplitude as 1 only. From minus 2 to minus 1, minus 2 to minus 1, both are rising edge. Consider in that way, so it will be easy for you. Rising edge means when we add both the signal, it should be rising only. At minus 1, the amplitude is 1. At minus 1, here also the amplitude is going to be 1 only. 1 plus 1 will be getting as 2. For that reason, it is going to be rising till 2. Then it's going to be at beyond the values for minus 1, near 0. Here it is, if I take in between value, that is minus 1 by 2. What's the signal you will be getting here also? Here also you will be getting as minus 1 by 2, right? Equally dividing, right? Okay, based on that. Then at here minus 1 by 2. Here at minus 1 by 2. What is the signal? If I go, it is greater than 1. Means maybe minus plus 1.5. Okay, greater than 1.5. Here negative 1.5. Here it is going to be minus 1 by 2. Here 1.5. You will be getting what? 1 only, but it is rising till 1 by minus 1 by 2. It will be rising. Observe here. It will be rising, rising at 1 by 2. Here 1.5. Here minus 1 point. What will you be getting? 1 you will get. 1 by 2. At 1 by minus 1 by 2, you will be getting as 1. At 0, you have to consider. Next. At 0, here it is 0 only. Right? Amplitude is not there. It's crossing at 0 exactly. And at 0, here amplitude is 2. Right? Means from minus 1 to 0, the signal is rising to value 2. Till it's 2, it is going to be reaching. That's what you have to write here. That's how you have to draw. Next, from 0 to 1. From 0 to 1. Before that, we'll erase the whole part. Then from 0 to 1. What is the 0 to 1 value? It is rising a triangle and the amplitude is going to be fixing at 1 only. Okay. Then here 0 to 1, 0 to 1, it is falling edge, right? From 2 to maybe, what is the in between signal? It's, if I draw a small circle, 1, it will be having amplitude as 1 only. Means, just observe here, I'm just drawing this part here, this part here, this part here, and this is a one more part. If I add both signal, if I add both the signal, I'll be getting the signal as a amplitude with 2 only. Add both, you'll be getting the signal like this. This is one part. How we can with the numerical values, how we can go for. Just observe here. From 0 to 1 by 2. In between one value I will take. 1 by 2. Here also 1 by 2. I'm going to add both the signal, right? Positive values. At 1 by 2, here you will be getting as 1 by 2, right? 1 by 2. Again, here 1 by 2, what may be the value here you will be getting? At 1 by 2, here 1, 1, here also 1 by 2. At 1 by 2, if I add the signal, here also 1 by 2, here also 1 by 2, will be getting as plus means 1, right? But the signal, what it's going to be representing, when I add both the signal, you'll be getting the amplitude. At 1, you have to check once. At 1, what is the amplitude here? 1. And again at 1, what is the amplitude here? 1. 1 plus 1, what it's going to be? Observe here, this signal is starting from 2. 2, it's going on and it is going to be reaching at 2. 1 plus 1. Observe here, this triangle, this whole triangle is added. This small triangle is 0 to 1. If I cut here, this triangle is 0 to 1. The triangle is of this, only of this part. If I add the triangle, if I add this to this part, okay, what I will be getting? I am getting the one whole rectangular pulse. This is what I'm repeatedly drawing, is adding of the signal of this with the signal of x or e of t, even part of the signal. In a graphical way, you understand. Okay, if I add these two, I'll be getting the whole rectangular pulse. Okay, this is how you will be getting of your x of t signal by adding even part of the signal and also add part of the signal. This is what we have to, how we have to solve the signal when it is given. In terms of the part of the signal, if it is given, means we can able to find what is our whole signal and also for the odd after signal. Okay, this is what this problem will be asking as 8 marks in the exam. Okay, next we go with the problems based on energy and power signals. This energy and power signal, we already gone through the equations. Same thing. Here the first problem it is given for us. That is, what is the total energy of the rectangular pulse shown in figure. That is from minus t by 2 to plus t by 2 with the amplitude as A. X of t is going to be taken with the amplitude as A, where it is varying from minus t by 2 to plus t by 2, and for other values it will be 0. This is how we wrote the equation. You have to write the equation. The question it's given, they given the pulse only. Okay. Then what is the equation for the energy? Total energy is going to be taken as E is equals to minus infinity to plus infinity x of t whole square of dt. Then here the signal is varying from minus t by 2 to plus t by 2. For that reason, limit is going to change from minus t by 2 to plus t by 2 x of t whole square into dt. What is our x of t here? With the amplitude is of a only. For that reason, determinant of a only, a square dt. If I integrate, I'll be getting as a square. This is the constant value. For that reason, a square. What is the dt integration? You'll be getting as t only. Okay, then the limit is going to change from minus t by 2 to plus t by 2. Just you apply the limit for the t. Upper limit is 1 t by 2 minus lower limit is of minus t by 2, minus of minus t by 2. If I do here, a square will be remains as it is, t by 2 plus t by 2. What is the, if I add both, I will be getting as a square into t joules, energy in terms of joules, for that reason. Then observe here, it is a non-periodic signal, right? Non-periodic signal is consisting of the energy. Energy is the non-periodic signal, right? That is going to satisfying here. Then what is the average power of the square wave shown in figure? Here a square wave is given where it is varying from with the amplitude minus 1 to plus 1. X of t signal it is given for us. The whole cycle is with a period t, half cycle is going to be taken as t by 2. This is how a signal is given. In a periodic continuous time signal, average power is defined for one complete cycle. Observe here, when we are going for a periodic means, it should be periodic with respect to time with continuously, right? For that reason. Observe here, it is not in a discrete, non-periodic, it's continuing, okay, continuing for that reason. One cycle. The period of the given signal is of what? One period means the whole cycle, one positive and also the negative, 0 to t. That is what t here it is noted, written. Then what is our x of t signal? X of t is going to be equals to 1 when 0 to t by 2 it will be 1. When t by 2 to capital T by 2 t, it's going to be taken as minus 1. That's what the equation is written. Then what is the power equation? That is p is equals to 1 by t integration. It is varying from minus t by 2 to plus t by 2 x square of t dt. But the limit here, it is going to changing from one complete cycle, right? For that reason, 0 to t. The same thing, 1 by t, 0 to t, x square of t dt. This is how you have to write. Then 1 by t is, it will be as it is. Then here it is, the signal is varying from two intervals, that is 0 to t by 2 and t by 2 to t. Then 0 to t by 2, it is, what is the value? 1, right? Here 1. So 1 square. From t by 2 to t, it's a minus 1. Minus 1 square. T by 2 to t, it is 1 minus 1 square. Minus 1 square means 1 only, right? Then 1 by 2, only you'll be getting an integration of dt. You'll be getting as t only. T with the limit 0 to t by 2. Plus here also dt will get. Integration is going to be taken as t. T by 2 to capital T. Then if I apply the limit here, t by 2 minus 0 plus t capital T minus t by 2. Next what I will get? 1 by t. Here t minus 2 minus 0 means t by 2 only. T minus t by 2 will be getting as t by 2. If I add both, I will be getting as t by 2 plus t by 2 is going to be t. Then 1 by t. If t get cancels, we will be getting as 1 as a 1 watt as a power of a square signal. 1 watt it should require. Okay, this is about the problem based on energy and power signal. Both are important. Both are asked in the exam for 6 marks. 6 or 8 marks depends on the question paper. Today we'll stop the session. Next we will continue in the next class.